Welcome back to geometry. We are going to talk about circle equations today. And when a lot of times I ask a student, I say, "What is the circle equation?" And they often respond that it's pi r squared or it's 2 pi r. That's the equation for the area of a circle and for the circumference of a circle. But I'm referring to is there a way to predict every point on a circle, to describe the infinite number of points that go around the center of a particular circle? And there is. And that's what we're going to talk about today. So it's worth first mentioning the definition of a circle, and I kind of put this together here. It says a circle is a set of all points equidistant from a fixed point. That fixed point is what we call the center. So let's say there's the center x1, y1, you see there, and I will make our circle is going to be will be every point. It's okay. Every point. There's an infinite number of points that's equidistant to that. One of those points on the circle is this x2, y2. Well, the way we're going to describe all those points is we're going to start with the distance formula. If I wanted to find the distance from the center to the outer edge, we call that the radius, right? Although I'm going to do something kind of odd here. I'm going to put a d there right now, which for distance. If I wanted to calculate the distance would be, we've learned from the distance formula, the difference in your x's, square it, the difference in your y's, square it, add together, square root the whole thing. There you go, distance formula. And that basically is a circle equation, but we don't really like the square root, so what if we just square both sides? The square root goes away. And then finally, when talking about circles, d stands for something very particular. It's the diameter, and this is not the diameter. This is the radius. So let's go in and just change that d and make it an r, let's say. Oops. Let's make it an r. There we go. So therefore, this would be an r also. And that makes more sense, and that is the circle equation. R squared equals x2 minus x1 squared plus y2 minus y1 squared. It's basically the distance formula where both sides are squared. It might make you think of something else. Wait a second. What's an equation where I have something squared equals something squared plus something squared? Pythagorean theorem, right? And it turns out the circle equation, the distance formula, the Pythagorean theorem are all about the same. Here's how I could get Pythagorean theorem out of this. Imagine you make a little right triangle out of this. This lowered length is x2 minus x1 because it's x2 beyond the x1 point. This length here is y2 minus y1. You see how you could have done the Pythagorean theorem and gotten this exact thing. So this is the circle equation. If you forget what it is, think about the distance formula. Think about Pythagorean theorem. They're all about the same. In this form, it is worth noting, R stands for radius. And, I forgot to do one other thing. This is the circle equation, yes. But we usually write it in a little bit different form. So I apologize for that. It's not really wrong, but let's see if I can do this. Hey, there we go. Let's get rid of these things here. Usually what we do, instead of writing it this way, we're just gonna say a generic x and a generic y. Instead of x1 and y1, we usually put h and k here, where h and k are the center. So say we go back and decide, let's call this HK. Now why HK? Well, H and K are usually letters that we consider constants. X and Y are usually variable letters. X, Y, Z, T, where the earlier letters in the alphabet typically are considered constants. And you're going to see this HK a bunch as you get in Algebra 2 and into college algebra and beyond. It's the center of circles, of ellipses, of hyperbolas. It's the vertex of parabolas. So you're going to see HK a great deal. So again, what I did is I generalized these as X and Y, and I picked particular point being the center for Y1, X1. And so I have this new form that does not have subscripts to deal with. And so this is the circle equation. And I should make one more note, which I've already mentioned, but that the HK is the center of the circle. Okay? We probably should do a quick definition of radius and diameter to make sure we know what that is. Radius is the distance from the center of a circle to, let's write circle, of a circle to its outer edge. And there are an infinite number of ways to draw a radius. Many times in math, which actually we saw, and we see in section 3 that there were clever ways and not so clever ways, which actually we've already talked about radius, so this is a bit of a review here. The diameter is a line segment. You know, I'm saying the radius is a distance. Probably I could have said that. It's, let's just change this. Let's say a line segment drawn from the center of a circle to its outer edge. Yeah, I mean, we often think of the length of a radius, but probably the radius itself is not the length, it's the line segment. Just like a diameter is a line segment drawn, let's just say drawn. A line segment with both endpoints on the circle. So I wasn't really planning on writing these definitions out, so I don't have them sitting here next to me, so I'm kind of winging it. But I think those are pretty good definitions. By the way, a diameter, you could really cleverly call it the longest chord. It is a chord. Remember we talked about that earlier. A chord is a line segment with both endpoints on the circle. And I missed something very foundational. A line segment with both endpoints on the circle such that it passes through the center. That's also important, otherwise it's just a chord. If you read the beginning of the definition, you think, oh, I mean chord. So I probably should write my definitions out in advance. So sorry about that, but you got to see it kind of developed. But we've already probably talked about those. So let's get into some actual problems now. And maybe we'll spend about 8 or 9 minutes doing a few examples. So the beginning of the examples are going to look like this. They're going to say, write the equation, that's my equation abbreviation there, write the equation of a circle with center 3, -4, and radius of 9. This is going to be quicker to do than the right. Well, here's our circle equation has this look to it, right? We put x's there. So the center is 3, 4, -4. So we'll put, notice the equation up here has minuses in it. So it's x minus 3, x minus -4, and then the radius is 9. And the radius is always squared. Let's simplify this to y plus 4. You don't want to do minus minus, and we can simplify this to 81. And that right there describes every point on this on that particular circle. Let's do another example. Kind of same idea, but now I'm going to say the center is 0, 0. You could also say that's the origin. That's the fancy name for 0, 0. Center 0, 0, and the radius we'll say is a square root of 17. So it would be x minus 0, quantity squared, right? Y minus 0, quantity squared, and you're thinking, oh no, what? Square root of 17, really have to deal with this? But you're squaring it. And when you square the square root of 17, you just get 17. X minus 0 is x, y minus 0 is y. So this one looks like this. This is pretty common that we work with circles where the center's at the origin, so get used to seeing x and y all alone. That means that that particular coordinate of the center is 0. Okay, it might be x squared plus y minus 4 quantity squared or something. Okay, let's continue to write the circle equations. This is kind of our, let's see if we can do this. Call this A, we'll call this B, we'll call this C. So write the equation of a circle now with the center at -8, 9. And I'm going to mix it up a little bit and give you a point on the circle. Is 1, 7. You're going to see this a lot in Algebra 2 and college algebra when they give you a point on the circle, or a point on the parabola, or a point on the ellipse, or a point on the hyperbola, whatever it may be. And what you're going to do is you're going to plug that point in, the x in for x, the y in for y, temporarily, solve for some constant, and then go back and let x be x and y be y. That's what always happens on these. So if we think of our circle equation, it is, let's just write it out and see where everything might fit. So we weren't given anything about the radius. The center is at -8, 9, so those will go there. And this point on the circle, this is really a particular xy. So I could put 1 there and 7 there. And look, everything there is known. The only thing I don't know is r squared. So this becomes 1 plus 8 and 7 minus 9. I guess I could have done that a little bit quicker, but so we have 9 squared plus -2 squared equals r squared. 81 plus 4 equals r squared. And you might be thinking, oh, great, I got to simplify this down. Actually, this can't be simplified, but even if it could be, we don't need to simplify it down, because what does the circle equation call for? It calls for r squared. So we finish this thing off now by saying, let's go back up here a bit. So you want to go back and let x be x, x minus a -8, and maybe you'll let me put a plus there, but I'll do it that way this time. Y minus 9, quantity squared, don't forget your squares, equals 85 goes there. And then, oh, why not? We'll just write it again. You don't need to take this extra step. If you don't want to change minus minus to a plus, you can do it all in one, but I'll probably do it here. And that is the equation of a circle with the center of -8, 9, and has a point on the circle of 1, 9. Okay, let's take a look at one more of these. see how we're doing on time. Okay. This one is going to say center. Same thing, find the equation of a circle, center 0, 0, point on the circle, -5, 0. This one, you think, oh no, that was so much work before. Can you tell what the radius would be? Because there's so many zeros here. You don't need to sketch these, but I'm just going to do it to make it clear. There's the center. There's the point. What's the radius? Radius is that distance. That's 5. I mean, how many steps does it take to get from 0, 0 to -5, 0? That's 5. So you could, on this one, just say x squared plus y squared, because the center is 0, 0, equals 5 squared, or x squared plus y squared equals 25. Now let's say you didn't think that. You could have done all this other work, which I'm just going to fly through and show you this. You could say x minus h quantity squared plus y minus k quantity squared equals r squared. That's nothing. This becomes 25. 25 is r squared. You can find r is 5, but we don't really care. Sorry about that. We don't really care. We just want r squared, right? So then you have x minus 0 quantity squared plus y minus 0 quantity squared equals 25, or that. So one like that, where it's one you actually don't need to do a lot of work to find the radius. You go a lot quicker. I think I'm going to keep going here. We just got 3 more examples. This might be a long video, but this will be all of 12.5. Next one up is kind of a new one, although this is the easiest type of examples. It's going to say find the center and radius. So before, you were given some characteristics like center, radius, point on the circle, and you had to write the equation. These, you're going to be given the equation, and you're asked to find the center and the radius. Well, the center is what? So what number must have been put there to make it a +5? It must have been a -5, because the formula calls for a negative. Similarly, that must have been a -4. The radius, we know, is the square root of that number, so it must be 3. Done. These are nice. What if we had x minus 6 quantity squared plus y squared equals 10? Center. What number was put there? Well, I guess a +6 because it's a minus. And it looks like they forgot to put a number on the y. No, that means the y chord of the center is 0. And the radius is the square root of that. We don't know the square root of 10. Well, we just write square root of 10, and it cannot be reduced. Finally, kind of our challenge problem for this section. This wraps it up here. So we'll take a few minutes. Let's say they ask you to write the circle equation. So back to that again. Where AB is a diameter. So you have some diameter AB, and A is for -1, and B is -5. Okay, so maybe you've discovered by now to write the equation of a circle, you need 2 things. What do you need? You need the radius, right? Because the formula calls for r squared. And you need the center. You are on a mission to find the radius and center. Must find radius and center. Must find radius and center. But we weren't given either. Can you get either of those? Think about it. You could make a sketch of this, but really, I don't want you making sketches of these. I don't think it's that helpful, but because you don't want to try to make a sketch and guess what the radius and center are. But the center, isn't the center, how does it relate to the endpoints of a diameter? It's the midpoint, right? So I need to find midpoint of AB, that will be our center. And we'll have task 1 complete. So hopefully you remember midpoint. You average your x's, add them together, divide by 2. You average your y's, add them together, divide by 2. And you get -1, 1. That's not right, -2, 2. And you know what would be nice if you're doing this problem? Label this as the center, because that is pretty important, that I'll be looking for that. I probably shouldn't box the answer. I don't know, to me when I box, that means it's kind of a final answer, but I'm just going to note this is important, like that maybe, because that's one of my 2 tasks. Now I need to find the radius. I could get the diameter with those 2 by doing distance formula, and some will do that. You can get the diameter and half it. But oftentimes it's difficult to half a number that's not a whole number. If it's the square root, people often have trouble taking half of like the square root of 180, which this would be. And that's a big number. Isn't the diameter is always double the radius? So if you want to deal with smaller numbers, find the radius, and it is usually much easier. To find the radius, we need the center, which, hey, we just found it. So the radius is a distance from the center, right, to either any point on the circle. So pick your favorite one. If one has a 0, go with that. If one has more positives, go with that. These, neither zeros, no positives, or not all positives, but so let's go with the one with smaller numbers. So the radius is the distance between our x's, -2 minus 4. So I'm looking at that minus that. Difference between the y's, which would be that and that. So 2 minus -1, add them together. So the radius is -6 squared and 3 squared, 36 plus 9, which is square root of 45. Now you might think, ooh, square root of 45, I can reduce this. I love reducing. And I'm just going to say, you don't need to do this, but I'll do it anyway. You could do that, you could do that, and be really proud of yourself, right? Now we're ready to write the equation of the circle. The final answer is x minus the x coordinate of my center, -2, quantity squared, y minus the y coordinate of the center, 2, quantity squared, equals what? R squared. Oh, you know what? This was wrong. Oh, no. Okay, this is right, yeah. But what is R squared? I could square this, or I could square this. What looks easier? This. R squared would be 45. You just drop the square root. That's the way to go. Oh, you know what? I should simplify that to a +2. And that is our answer. That's a really nice problem though. You have to think a little bit. They didn't say use midpoint. They didn't say use distance formula, but you need them both. I strongly encourage you to find the radius first, and then find the midpoint.